Today I will talk about the T-shaped and Seasaw geometries. So in the T-shape, we have two lone pairs and coordination number of the central atom is 3. So the basic formula for this shape of the molecule is AB3E2. And if I draw the molecule, this is our central atom, okay? These are the other atoms. And we have two lone pairs. One of them is goes to the back and the other is come to us, okay? So instead of drawing like this, so this is the T shape, I want to draw the lone pairs by using a little bit of organic chemistry notation, okay? Since this is so this is in the back and this is in the front position. So these are the lone pairs. This is the T-shaped structure. And one of the example for this molecule is ClF3. The important part is that what is the angle? For instance, what is this angle? Is it 90 degree? It should be close to 90 degree, but if you look at our previous video, you should know that bonding pair interaction is smaller than the bonding pair lone pair interaction, and it is smaller than the lone pair and lone pair interaction. So here we have a lone pair bonding pair interaction, and this interaction is stronger than this interaction. Therefore, the angle from these two atoms should be less than the 90 degree. Okay, it should be less than 90 degree, and this is also less than the 90 degree. Moreover, so another thing is that, so actually this is the same thing, this angle from here to here is approximately 175 degree due to the lone pair bonding pair interaction is higher, so these two things repel each other stronger than the bonding pair. Therefore, the angle from here to here is approximately 175 degree. And the other structure is the Seasaw, which is another harder example for the VSEPR theory. In Seasaw, we have one lone pair, and we have 4 atoms around the central atom. So the other representation is that coordination number for the central atom is 4, and I can delete this. We can keep in mind that. And this kind of molecule says AB4E. So if you look at the table, like the previous table, we see a seesaw structure, and if I draw it, we have a central atom. This is a central atom, okay, and these are the other atoms which is connected to the central atom, okay. One of them is coming out and the other is going back. So maybe this is more correct. This is the front and this is the back. Okay, and we have a lone pair. So these three things, lone pair and these two atoms, is on the same plane, but one of the atom is the back and this is in the front. Okay, hopefully you understood. So I can delete them. So this is the seesaw structure. But what is the bond angle? So to understand the bond angle, we know that this information. If you don't know this information, then you might have some trouble in the exam. So bonding pair interaction is small, as I said, but the bonding pair lone pair interaction is stronger, so that this angle and this angle is bigger than 90 degree. Okay, actually it is exactly 129.2 degree for the SF4 molecule. So this is the sulfur atom, green one, and these are the fluorine atoms in this case. I want to make two similar examples, and the first one is water and the other is CH4 or methane. So firstly, we know the Lewis structure. I can draw it very quickly. This is the Lewis structure. So we have two lone pairs and two hydrogen atoms. So AX2 E2 is the representation of the water molecule. If you look at the CH4, this is the Lewis structure of the CH4, and AX4 is the representation for the CH4. As you remember, water has a band structure. However, what is this angle? Is it 109.5 degree? The answer is no, it is not. And I want to explain it in this video. Well, firstly, methane has a tetrahedral structure. So I can draw methane inside a cube. We have two hydrogen atoms on the bottom and two hydrogen atoms on the top, and the carbon is in the center. So in here, bonding pair interaction exists. So from here to here, from here to here, and from here to here, we have only bonding pair interaction for the methane molecule. Therefore, the angle is 109.5 degree between the hydrogen atoms. So this angle is 109.5 degree. Similar thing can be done for the water molecule. Again, I will draw a cube. We have two hydrogen atoms. Oxygen is in the center. So maybe this is the oxygen. Okay. And we have two lone pairs. These are the lone pairs. So this is the hydrogen and this is the water molecule. But we know that bonding pair interaction is less than the bonding pair lone pair interaction, and the lone pair interaction is the strongest interaction. This is the strongest interaction. So here we have lone pairs, and this interaction is high. So this is the strong interaction, and this is the weak interaction. If the interaction between the hydrogen atoms is weaker than the lone pair interaction, this angle should be less than the 109.5 degree. And this is true actually. And the water molecule has 104.5 degree bond angle. If you have a question, you can ask in the comment section. And thank you for your attention.